Hello students, sometimes geometrical interpretation is more convenient to understand difficult concepts in mathematics. As you are aware that rational numbers can be represented on a number line. So question arises, how to locate irrational number on a number line? Here we shall construct a square root spiral depicting some irrational numbers as well as rational numbers. And through that, we are going to demonstrate the location of some of the irrational numbers on a number line. To do this activity, material required are a cardboard, pen, pencil, compass, scale, protector, thread and a rubber. Let us perform the activity. Let us take a cardboard and on this cardboard, we draw a line. As you can see, now on this line, we are going to choose a point O, anywhere on this line. Now, we are going to draw a line segment OP1 of unit length. Now, with the help of this protector, we are going to draw a line segment P2, P1 perpendicular to this OP1. You can see that P2, P1 is perpendicular to OP1. So students, you can see that P2, P1 is a line segment of unit length perpendicular to OP1. Now, we join OP2. And by using Pythagoras theorem, you can see that this OP2 is under root 2. Now, again we draw a line segment P3, P2 of unit length on OP2. So, you can see that P3, P2 is a line segment of unit length perpendicular to OP2. Again we join OP3 and by Pythagoras theorem, you observe that OP3 is under root 3. Again we draw line segment P4, P3 perpendicular to OP3 of unit length. So, P4, P3 perpendicular to OP3, you can see after joining OP4 by using Pythagoras theorem that OP4 is coming out to be under root 4. You can show these OP2, OP3, OP4 with the help of thread. So students, continuing in this manner, we have created a beautiful spiral. As you can see that this spiral is denoting some of the rational numbers as well as irrational numbers. OP2, OP3, OP4, OP5 and so on are depicting root 2, root 3, root 4, root 5 and so on. Now, how to locate some of these irrational numbers, for example, these root 2, root 3 on a number line. Let us see this. You can see that this OP2 is depicting root 2. Now, we take a compass and taking OS center and OP2 as radius, we draw an arc. And this arc will intersect on a number line at some point. Say that point be A1. And this A1 corresponds under root 2. That is, the distance OA1 is representing under root 2. Now, to locate under root 3, taking O as center and open the compass up to OP3 as a radius, we again draw an arc. And this arc will intersect the number line at some point, say A2. And this A2 corresponds under root 3. That is, OA2 represents under root 3. Students, continuing in this manner, you can see that we have located some of the irrational numbers as well as some of the rational numbers. As you can see, OA1 is representing root 2, OA2 is representing root 3, OA3 is representing root 4, OA5 is representing root 6. Students, it is very interesting to know that you can locate some of the irrational numbers with different activity as well. As you can see in this model, 2 thermocol or wooden strips are attached perpendicularly, and on it 2 scales are pasted. Pins are fixed at a unit distance starting from 1 on a vertical strip and a pin at 0 on a horizontal strip. Students, you can see that a wire is being attached to it. Now students, you can see that OP1P2 is forming a right angle triangle, and you may observe by Pythagoras theorem that OP2 is representing root 2, as OP1 is of unit length and P1, P2 is also of unit length. Now, to locate this OP2 on a number line, what we have to do? We will stretch this pin and rotate in a clockwise direction, and it will intersect the number line at some point, and this point corresponds root 2. That is A1. If this point is, say, suppose A1 is representing root 2. Students, again see this, that OP1, P3 is again forming a right angle triangle, and this OP3 is representing root 5. Again, to locate this root 5 on a number line, what we have to do? We'll stretch this pin and move in a clockwise direction. It will intersect the number line at some point, and that point corresponds to root 5. So students, you can see that this OA2, if A2 is the point of intersection, then we can see that OA2 is representing root 5. Students, similarly, you can represent root 10, root 17 and many such irrational numbers on a number line. So students, we have observed how to locate some of the irrational numbers on a number line and representation of some of the irrational numbers and rational numbers on a beautiful square root spiral. Thank you.